The entire framework is ready. It is time for the algorithm to learn. We said that's done by varying the weights and the biases. Before this happens though, we must set the arbitrary values from which weights and biases start. This is the process known as initialization. So, let the initializer be equal to tf.globalVariablesInitializer brackets. That's the method that initializes all tensor objects marked as variables. We have two, weights and biases. They will be the only ones affected. Okay, did we initialize? No, we haven't executed yet. So how do we execute? Execution is done through the method run applied to the session. For each execution, we must type ses.run, and in brackets will indicate what we want to run. Therefore, to initialize the variables, we must write ses.run initializer. Awesome! The variables have been initialized. Around this time, we usually import the data. Our training data comes from the NPZ we saved a couple lessons ago. So, training data equals npload, tfintro.npz. Once again, this method will only load the file if it is in the same directory on your computer. Otherwise, we must specify the entire path. What is left is the for loop that would minimize the loss function. So, for e in range 100 semicolons. E stands for epoch. Each iteration over the full dataset in machine learning is called an epoch. From now on, we'll use this term to describe iterations and number of iterations. We still have 2 lines of code we must go through. Hold on tight, please. Let's call the loss at the current epoch cur loss. This is basically the same as we had earlier. We will calculate the loss function at the end of each iteration or epoch. Let's look at the syntax in TensorFlow. Cur loss is equal to ses.run, of course, since we want to execute something. Then, in parentheses, we have 2 arguments. The first argument is a list in which we must state what we want to run. In this case, we would like to run the optimization declared earlier. I will also compute the mean loss, as I want to be able to print it later. The second argument is feedDict. It tells the algorithm how the data is going to be fed. The syntax is feed_dict equals braces. Now we must instruct it which placeholder is fed what. First, we put the placeholder, so inputs semicolons. Then, we feed it from the training data, the tensor called inputs. That's the syntax. Recall that training data was where we located the NPZ file. The 2 labels of the NPZ file were inputs and targets and are self-explanatory. Similarly, the targets come from our NPZ and were labeled targets. So, we have comma, targets, semicolons, training data, targets. And finally, we must close all the brackets we used. That's it. The meaning of this line of code is the following. Run the optimize and mean loss operations by filling the placeholder objects with data specified in the feedDict parameter. Cool. There is a little programming trick some of you may not have seen. Since every method returns something, the cur_loss will actually return something for optimize and something for the mean loss. The mean loss is a value, and we already saw that. However, optimize doesn't return anything. Its output is always none. The underscore is a special symbol to disregard a return value of a function. We don't need the return value of optimize, so we'll disregard it. Okay. Finally, I'll print the loss at each epoch. That's our final machine learning algorithm created with TensorFlow. There are just 10 lines of code specific to the problem. Let's run it. Naturally, we get the same result. We can further plot the data. I won't go through the code, but you can see the explanation related to it in the course resources. The point is that the graph is the same as before. Alright, there is no need to comment on the actual result. it is far more interesting to comment on the use of TensorFlow. Notice that the loop we used was so generic we can apply this exact same code for different machine learning algorithms. It calculates the current loss, given an optimizer, a loss function, inputs, and targets. All these arguments were defined before the loop using the TensorFlow structure. Whenever we need to build a new model, we can change the appropriate objects rather than modify the loop or structure as a whole. TensorFlow code is extremely reusable. Further on, we will see that iterating through the data is not always so simple if we want amazing results. This proves useful in real life, as the code you'll need doesn't need to be adjusted too much, and it is easy to share your code with others. Okay, this was our introduction to TensorFlow. In the next few lessons, we will dig deeper into the theory of neural networks. Please complete the exercises, as they will introduce you to additional TensorFlow concepts. Good luck, and thanks for watching.